Okay, so I'm going to take you through the basics of low-level programming, otherwise more commonly known as assembly language programming. Okay, and I'm going to start by looking at the features of the language programming, the syntax, and then we're going to look at a few features of assembly language programming, and then the uses of assembly language programming for problem solving. Okay, so first of all, syntax, we can broadly break these up into different categories. We've got data movement instructions, which is basically loading data from memory locations into registers. And then storage instructions, which is storing from registers into memory locations. Now, there are a few different, I suppose, subcategories, and depending on the addressing mode that's being used for each of these, for loading and store instructions. And I will look a little bit closer at addressing modes a little bit later on. Okay, so basically we've got you essentially, when we're talking about data movement, we're talking about moving data from memory into registers, or the other way around, storing data from registers into memory. Next, we've got arithmetic operations. Now, these are quite straightforward. We've got add, which we can add a number from a memory location to the value that's currently stored in the accumulator being the register that holds the results of the last operation that has been carried out by the processor. Decrement, now we can decrement a register value. Now that might be the accumulator, that might be an index register, it might be. It depends on very much the architecture of the processor itself and the assembly language that processor has. But decrement simply means reducing by one, increment increasing by one. Okay, now depending on what register that is being applied to, depends very much on the instruction set that we've got. However, in for the Cambridge exam, it's accumulator or in the index register. Okay, then we've got comparisons and jumps. Now, again, it's fairly straightforward. Comparison, we can either compare with a value that's held within a memory address, or we can have a value, I suppose the equivalent of immediate addressing, which we'll look at shortly. But you essentially, you're comparing the value in the accumulator with another value. Then we've got the jumps. So really, JPE and JPN, jumping if the if a comparison is true, would be JPE. So if you had a comparison and the new number in the accumulator was the same as the number you've been told to compare to, then you would usually follow with a JPE. So saying or JPN. A JPE is you jump to a specific location if the comparison was true, and JPN, you jump to a location if the result was false. And then we've got the straightforward jump, which is jumping to, okay, which has its high-level language equivalent of the good old go-to. Then we've got input and output instructions. Now, input is it converts the ASCII value of a key that's pressed by the user into it converts into an ASCII value, and then that's stored in the accumulator. Output takes whatever number is stored in the accumulator and outputs it as its ASCII equivalent. Then we've got some of those the allowable syntax. We've got end. Now, end is actually quite important because when we're executing an assembly instruction, when it's converted into machine code, because we're dealing with sequential, or very often sequential, instructions in memory locations. If we don't have that specific instruction indicating the end of a program, the processor may attempt to interpret or execute the next memory location's value, which may be a value that's totally unrelated to the program itself. So we need that end to indicate, right, we hand control back over to the operating system. And then we have symbolic labels. Now, symbolic labels are used really for the programmer's benefits, where we can assign names, symbolic names, labels, basically, to different features. Now, that could, of course, be an instruction, or it could be an address. It could be a location. We can give those names, and those are converted by the assembler into um, absolute address locations.